Hello guys, welcome back to the journey video. As I already started my journey video, I will going to be start today's topic. We are going to be cover the three problem, which one is longest repeating character replacement, then permutation in string, then minimum window substring. Uh, these are the problems we will going to be cover in these sessions. So as you know guys, I'm preparing for the top MNCs, DSS and other stuffs. So if you think you also wanted to be learn and you wanted to be prepared, just be with me. You can access this Excel sheet as I already shared this in description box, so you can refer to your preparation. I have planned everything over there, and yeah, that's it about the my things. And if you feel you wanted to be connect with my journey, just like and subscribe to the video and stay with my journey. Let's start our first problem, longest repeating character. So let's see the question. What does question said? So question states about the you are given a string of s and integer is k. We will get the string with string and k is the integer basically in the number. And what we wanted to find, you we have to choose any characters of the string and change it with another uppercase letters. You can perform the operation k times and return the longest substrings contain same letter. You can after the performing the above operation. Let's see if we get the string of ab. So we wanted to change k time characters and create the some strings which contains all similar number of character, similar character basically. In this case we have the k operation. We can remove change the k characters. Let's see ab. I will remove the uh, bb from this, and we will uh, return the substring a four times. That's why we are going to be return the output length of that string is 4. Okay, so let's take this example for the iteration. I will take this example for the iteration. Let's jump into the uh, explanation what exactly I wanted to and how will we will going to be approach this. Okay, now, as I already said, in these questions we have the constraint. We will check the constraint. Our string length will be the 10 to the power 5, and s contain the uppercase English letter only. As you can see, it means it's give the some intention behind it. Like getting writing the constraint is question tells itself we have something to consider, as they are mentioned in the questions. Okay, constraint. So now uh, we will iterate everything's in one go. Let's see. uh, we will see the brute force solution first of all. Let's say I started the my I with the first position and my j will be the something over here. What I'll do, I will do the increase my from here to here and check. I will check the my previous value with this. Let's say I will check the my j over here, and I found one operation. I will reduce the k into the 0. Now my k is 0. Now I don't want it to be uh, change k basically. Now I will check whether a is equals to the my starting element. It's present, so my total maximum length will be the this, because when we go on b we will get the we have to reduce, we need one more operation to do, but we don't have right now, so we will return the 4. Similarly like that we will going to be do for the entire thing. Okay, so yeah, for next, let's see. Now I will be here first position, and then I will going to be at rate. Now we will return the um, maximum will be the will going to be changed. So brute force is taking time complexity of big of n square. N is the length of n square. Okay, n is the length of the string basically. Okay, so interview will ask you the optimize this solution, because you understand what I wanted to. If you are doing a little bit coding, you got the solution basically, brute force solution. Now, come into the optimization. Can we do optimize to this? So we can do. Okay, so we can do this based on the sliding window. Okay, so as you know, what does mean by sliding window and how we're going to do. So basically, as you can see, let's take this example for the iteration purpose. So let's see my window is something, my I is at the zeroth position. Okay, and my j is something one position. Now as you can check, the we are what we are calculating right now, we are calculating the window which contain the k time k time different elements. Now what we are going to do, we will going to be maintain this and our maximum frequency element. Okay, maximum frequency element, let's start with this. Now 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 my maximum frequency of in this two window we have only maximum frequency 2 and our case remains same. Okay, now I change my j into the 2. Now with this three uh, character, we have to change k, because we need to change the b into the a, and this k will be going to be 0 now. Earlier was 1, now 0. Okay, so next we'll go a. We'll check the maximum frequency of the a. How much? 2. Okay, so now this will going to be 3. Okay, so what does it mean actually? What does it mean? So every time when we are iterating, we are checking our j minus I, basically plus 1, as we are doing plus 1 is greater than or equals to, if suppose I will remove the my maximum frequency is greater than to the k. If it is true, then we have to proceed. Let's see now, check this one and take consider of this one and then do the iteration. Let's see now, my I is 0 and my j is 2, and maximum frequency is how much maximum frequency we do have right now. Let's see, start with the 1 1. This is 1. Okay, I will going to start this one. J is 1 and my maximum frequency of A is 2 right now. Okay, now if I calculate, my J is 1 minus 1 plus 1, maximum frequency is 2, is greater than K? Nahi hai. So what, I will not going to do anything. I will just change my J into the 2. Okay, now my J is uh, here now b, and maximum frequency will going to change? No, because my frequency of b is only 1 right now. So what we are going to, maximum frequency remains same. Now 2 minus 0 plus 1. Okay, 3. 3 minus 2 is 1. 1 is greater than 1. Yes, obviously greater than 1. Not greater than, sorry, not greater than 1. So we are not doing to anything, we are just increasing the j with the 3. Okay, now we are at the position of A. Now our maximum frequency is 3 of let us see, my maximum frequency of A is 3. Okay, now what I'll do, I will check this. J 3 minus 0 is plus 1 is 3 minus 0 plus 1 is 4. 4 minus 3, how much it is? 1. Okay, so we'll not going to do anything. Now we'll move into the 4 right now. Now B, how much B it is? B frequency is 2 and our A frequency is 3. Okay, so sorry, this will going to be 5 now. 5 minus 1 plus 2, how much it is? 5 minus 0 plus 1. So like this we are going to be solve this. So you understand what I am into it. So let's jump into the code what actually we wanted to be do. So let's start. So I need the maximum as I already said. So I will maximum calculation as of now. Then I will need the left side pointer to check the left side. Then I need to have the frequency of the particular character. So I will create the frequency of the frequency array with the character of 20 length 26. As they already said, we have the constraint of 26 like uppercase character only. So we know the uppercase character is 26 only. So we will going to be change store the frequency in this character only. Now what I need one more pointer I need. So maximum frequency as of now is equals to 0. N- okay, so now I will going to be loop for from I 0. Okay, so I will start the my right pointer. So I will mention this right pointer. Right is equals to 0. Just right is less than what the length of string, then then a right plus plus. So as we already know what we wanted to, we need the index. Actually index of we have to check the what we can say, check the frequency of that particular character. So we will get the index of the characters which present in the string. Okay, so how we going to, yes, dot char at of right minus a. Okay, so now we have to increase the frequency of that particular character. So what we are going to be do, we are just have to be increase that frequency plus plus. Okay, now our major part come into the picture right now. So as I already said, what we want to, we have to calculate the maximum frequency as of now. So how we going to be do, so we have the current index and correct characters. Let's see B, we will going to be check the B's frequency at that particular moment. So what we are going to be the max of max frequency is equals to mat dot max of max frequency of earlier what it was, and my current element's frequency. Okay, so this will going to be written our us the maximum frequency of the character as of now, whatever it is. It may be A, it may be B, it depend on that. Okay, so now we already shows us one formula, this one, and this is the most important formula. While our right minus left, if what it is mean, it means we have considering the window. As we already uh, no, the we don't wanted to go the don't wanted to change the more than k element. So this minus maximum frequency, maximum frequency is going to be higher more than k. It's mean that we have the different elements present more than k time. So what we're going to be do, so we are going to be increase our left pointer. Before we increase the left pointer, we have to change the frequency of that character from our frequency table. So what we're going to be do, so s dot caret, I'm doing shortcut here, left minus and minus minus. So this is shortcut basically you can do, and then I will going to be change my left by 1. Okay. And now as we want the maximum length, return the maximum length. So every time I will do check the maximum window. As of now, math.max of max, comma, my right minus left plus 1. Basically this will going to be return the window, and that's it. We will going to be return the maximum. As question said, we have to return the maximum window. Now we're going to be run the code. mm, what did it mean out of bound? Oh, 7. How does it possible we can the let me debug the little bit. Not character. Okay, index. mm, I think this should work, but character of right minus a, we are getting the index of that particular character, and then we are going to be reduce the by 1. Let's see, let's get the first of all int id of is dot char left minus a. Now we'll get the index, and then I will reduce the index. Still we are getting the out of bound error. Oh, sorry, this will going to be the maximum. Oh, by mistake. We have to shift the, sorry, my bad. With silly mistake. Now you can see it's pretty much faster than efficient. Okay. So now this was the longest repeating character. Let's start with the other one. As I already mentioned, the next problem is permutation in the string. Okay. So now what we wanted to be do? We wanted to be check the permutation in the string. Let's see the question. What exactly question said? We have the uh, two strings s1 and s2. Okay. So and we wanted to check S1 is S1 is present or not in S2. Basically, you have to find the permutation of the S2, make the permutation of the each and every element, and check whether S1 is present or not. So let's talk about the uh, solution. Okay, let's see the solution first of all. Brute force solution. What exactly we wanted to be do and how we're going to be approached. So let's see. Think the we already we may solve the problem of the combination of the string. So now we will going to be do the all we will going to create the all combination of the given string, and then we have the other string where we wanted to be matched. So, and then we will going to match the these strings whether it is content or not in that particular permutation. Now we're going to be create the permutation array. Uh, so now currently we do have the permutation of the e. Now we're going to be check the permutation of ai. Okay, so next we'll consider the string aid. Okay, aid. Similarly, aid b is the one another permutation. Okay, so then EIDBA. Okay, now AIDEIDBAO. We'll consider this string as well. Then AIDBAOO. Similarly, AIDBAOOO. Now, similarly, now we'll check the permutation of this element. Similarly, we'll going to be do the same next string with the remove the e and then start the our j pointer is from the I. Then our next string will be like this: a I, then id, then I db dot. Similarly, next will be the ba b, then ba, and then dot. Okay. Now we're going to be check the permutation of the each and every string. Now we want only this string. How we're going to be do? We'll check the our um, hash map. Let's see, we have the hash map, frequency hash map of this. Okay, frequency hash map of this strings. Okay, now we will check the frequency hash map of the each string. So we'll check the whether frequency of the two elements is similar. Then we check this one. If it is frequency same, if it is frequency same of this particular how do you can say string, so this mean that means that we can uh, create the create the permutation of that particular thing particular string. Okay, let's see here. We have the frequency same with this, then we are going to be return true. This was the brute force solution. This in this case we'll going to be have the time complexity big of n square. N is the uh, n square, and time complexity going to be space complexity will going to be the big of n square only. Okay, n square only. Now, as you can see, we have too much time complexity and space complexity. So, can we reduce this? So, definitely yes. As we already solved the window solution, so we know already the what actually we are doing? We are doing the window. We are taking the window and then we are iterating over that. So now let's start with the uh, thinking about the window. Let's see, we have the ABC. What we are going to do? We are going to do the frequency array. Let's see, we know as the constraint we already do have. So constraint says that we have lowercase alphabet letter only. So now we are going to create the 26th number of array. Okay, now we are going to be store the each and every frequency of the given input string. So let's see, we have the AB. Now we are going to be store the frequency in this index 1, because A is at the starting zeroth index and B will be the at the first index. Now we don't have the anything, and other places we do have the 0 0 0 0 0. Now what we wanted to do, we just have to convert this array into the code only. Consider this as the code. Okay. Mm, this is the code, and you have to just compare this code with the your current, let's see, current frequency index code, frequency index of this code. Let's see. Now, do we need these things create every time? No, because we already doing the we already doing the windows, considering the windows. So let's go with the windows. Okay, now let's consider the our I pointer, left low pointer or I pointer over here, and then we are going to be shift over here. And next time what we are doing, we will going to be check the length of this string, and we're going to be consider our window with this length. Now let's check the A and I. Okay, so my window will be like this, but my length is more than that. What does it mean? What does it mean? So my window size does not contain this frequency element. Okay, so now we're going to be increase our uh, right pointer and move, and our left pointer will be going to be over here. Let's see. Let's go with the index by index. My left pointer will be the zero, zeroth position, and my right pointer will be the one position. Now we're going to be check whether to our frequency, current frequency uh, matches with the our other frequency array. Let's see, we do have the iteration frequency array which contain the 26 um, number of elements. So now I will change the each position frequency 1, then ith position frequency somewhere 1. Okay, so this will be the somewhere, and then I will check whether now whether the my hash code, this array is equals to this array. If not, then it's not contain like this window does not contain the permutation of this particular string. Now what I'll do, I will shift my left pointer to the 1. Now as we are here, my right pointer at the position of 2, and my left pointer I will going to be shift the by the 1, and then I will going to be change my uh, reduce my frequency of the zeroth position. This will going to be 0. Okay, now my right pointer will going to be 3 now. Okay, so this will be the 3, and at the third position we do have the D. So what we are going to be do, we will going to be change the frequency of the D by 1. Okay, now similarly uh, we'll check the current code, array code is similar to the, no, then we'll going to be increase our left pointer by 1. This will be going to be 2, and this our right pointer will going to be 4, and then we are going to be change this frequency to the 0. Okay, next we will reach the position of the A, like we have the B and A. Sorry, we will going to be reduce the frequency of E, not the B, because we our last pointer is B only. Okay, so I only, and similarly day. Let's see if we reach over here and our frequency table something like this, and this will be, and this will going to be 0. Now, as you can see, this frequency array and this frequency array is similar. It means that in this case we will going to be return the we will get the permutation of the this string. That time we will going to be just return the true, else after iterating every time, every window will going to be return false. If we are not getting the same cache code, then we will going to be return the false. Okay, so this was the approach, and in this case we are going to be time complexity will be the big of n only, because at one time we are going to be we are iterating, we don't doing anything else. Yeah, and space complexity will be big of 26 only, because we need the 26 integer array and nothing else. Okay, so this consider as the constant only. So that's has the time complexity and space complexity. Then let's jump into the code basic. Now, what actually we need first of all? Okay, so let's consider the base case. If my S2 is greater than S, my if my S2 is greater than S1, it's in that we won't able to find the combination of the S2 in S1. So have to just check the base case. If my S1 dot length is greater than S2 dot length, it's mean that we will not going to find any combinations, and we have to just return the false. Else else we have to do the our things properly. First of all, what we are going to do, we have to check the frequency of the x2, as we already did over here. So yeah, we are going to be check the frequency. Now we need the frequency array, frequency array with the 26 character, as they mention in constraint. We have only 26 alphabet, lowercase alphabet. So we're going to check the frequency. Now we have to iterate from the 0 to, we have, I will be less than s2 dot length. We have to iterate each and every element and check the frequency of the each character. So now frequency of char s dot caret add of I position minus a, and then just increase by 1. That's it, nothing else. Now what I'll do, I will not going to be check the each and every element every time. So what I'll do, I will make this array into the string, so a string can check in a one go. So now string code 1, I will consider this as the code 1, and I will convert arrays dot to string with given array. Okay, so frequency array. Now I will get the frequency of this, frequency of the let's see the code of this string with the frequency. Now I will going to match every time this frequency with particular window. Now for window, what we need, left pointer is equals to, what we also need, we also need the new frequency element, new frequency array, where we can check our last frequency, like previous this code with this frequency array. So now frequency of new. Okay, with the 26. Now what we wanted to do, we have to iterate each and every element from this. So now we're going to just looping the for loop int I is equals to 0, I is less than s1 dot length, and then I will just move into the one. Now our major part, now we have to change the frequency of this, what we can see with new frequency. So sorry, okay, frequency of new array with s1 dot caret at of ith position minus a. We now we have to check the window current what, let's see my j is something over here, but and our early size of s1 is 2, and my j lower pointer is here, and we elements inside this window. It means that this window will not going to be permutation, because we our current string size is 2 and we are getting the 3, so we have to reduce our our left pointer by 1. So let's see, increase by 1, so will get this 2 window, and then we are going to be match our current frequency current frequency window with the uh, earlier code basically. And now while my I minus low, I minus basically left plus 1 is greater than s1 dot length, as I already, and gth length. If it is greater than, then we have to do something, we have to shift the our left pointer by the 1. So to shift our left pointer, we have to change the frequency as well. So this will something like this, sorry, this will something like this only. Okay, and we have to change the left, reduce the frequency of the left and increase the left pointer by the 1. Left plus plus. Okay, now after this we have the frequency code, and as I already said, in particular window we are going to check this code with this particular code. Then we have to need convert this new frequency code. So I will going to be say code 2, then arrays dot to string array to string of frequency of new. Okay, and then if my code 1 is equals of code 2, then we're going to just return the true. So as you know, in Java, if you use the double is equal double, we're going to be map the by double equals to this will going we will going to be return the false basically. The to map the to check the string, we have to use the equal. That's why I use the equal, then we're going to be return. Else else we done with iteration, we are not get anything, so we have to just return false. It means that we will not going to be get any frequency with same. Okay, just run this code. Oh, what happened? length s, oh, this is something by mistake, silly mistake. Oh, S, not S, it should be the S2. Oh, this will be the S1, sorry, my bad. This will going to be S1 because we have S1 then S2, S2, S2 because that's it. For Q, spelling mistake as you are solving a problem. So we did some mistake. We have to debug this. False. Oh, this will going to be S1 only because we don't want it to be. Now that's it. Yeah, this is very pretty much efficient. That's what it is, and this was the things. We do have one more question, minimum window substring that will going to be covered in next journey video. That's it for the today. Thank you for connecting with me. And if you think this video is going to be helpful for you, just like and subscribe to my channel. Thank you guys.